Alright, so we're going to have a look at finding square roots of a complex number. So what we're going to do is take the square root of a complex number of z equals x plus yi to obtain the square root. Okay, so in other words, we've got a complex number, x plus yi, okay, and we want to take the square root of that. Okay, so we set that equal to your a plus bi, which will be the format of your solution. So we're set. And then we want to square both sides. So x plus yi is going to be a plus bi all squared. Okay, expand the right hand side. A squared plus 2abi plus b squared I squared. So it would be a squared plus 2abi, take away b squared. Of course, remembering your result from I squared is -1. Okay, so that means we can now match the real part and imaginary part. Okay, so using the equality on identity. So your a squared take away b squared, the real part, must equal the real part of this side. Okay, and the imaginary part, 2ab, must equal the imaginary part over here. Okay, and this is the concept we use to solve our square roots, to get square roots of a complex number. You're not happy. Perhaps this will help. Find the square roots of 5 take away 12i. Okay, so what we are effectively doing is doing that, finding that square root. Right, and we're using this property here. So, a squared take away b squared is equal to x, which is the real part of your complex number, which is 5. And, right over here, 2ab, the imaginary part is y, which is -12. Don't go dying on us. Alright, so now what you need to do is solve for a and b. Okay, so when you solve for a and b, you'll get your solution for taking the square root. Make sense now? Right, so how am I going to solve? Simultaneous equation. How am I going to solve? How am I going to solve simultaneous? Sorry?
A is -6 over 4.
Yep. Okay, so solving doesn't matter which way you go, you should get the same answers. I actually did A anyway, it will work for B as well. Solve B, sorry, it will do for A. Right, so number 1, this is number 2, put that into number 1, eliminate one of your variables and solve. -6 over b all squared, take away b squared is equal to 5. Alright, what's the next step? You need to solve for B. What do I need to do now?
Put B up, times it by run B squared.
Always remove the denominator. Okay, put everything onto the one side, make b to the power 4 positive. So move everything onto that side. Okay, this is like a quadratic, isn't it? Okay, so it's really b squared or squared plus, hang on, I won't get that far. This is like your x squared plus 5x take away 36, isn't it? Okay. Yep, okay, and that's what we're going to, one of the last thing we're looking at in your mathematics and quadratic function. Okay, but for now we will just press on with it. Right, so if we treat it like this, what two numbers multiplied to give negative 36, the same two numbers to add to give positive 5. You don't need to.
You don't need to?
Nope. No.
8 and 4.
No. 8 4 is 32, by the way.
I made that mistake in one too.
Isn't 9 4 is 36? Isn't 9 4 is 36?
Yeah. I still do that.
What's 9 take away 4? Alright, so b squared plus 9, b squared take away 5. Ah, that's why we, yeah. Now there was a reason why I did b equal, not a equal. Actually it doesn't matter. Just grab that. Alright. Sorry, 4. Alright, so b squared is equal to negative 9 and b squared is equal to 4. Alright, can I continue with this one here?
Well, you can.
Why not?
Well, you
Enough
can be
extension too.
Well, there is a reason you cannot continue with this one here. Why?
complex.
What is b? Is it an imaginary number though?
No, it's just a coefficient.
Just a coefficient, isn't it? So the b and a still need to be real because the imaginary part is labelled with the I. Okay, so when you have this, yes, we can write down this as an imaginary solution. However, it has to be a real number, doesn't it? Okay, so for this one, there is no solution because it doesn't match what we're trying to do up here. Okay, and of course this one, the b is plus or minus 2. Okay, into number 2. So when b is 2, a is equal to negative 3.
Can we just complete this table and have the extension to now?
Oh, this is assumed knowledge by now, Robin. Alright. It equals negative 2, a equals... Okay, so mathematics and extension 1 are assumed knowledge for your course. Okay, because they expect if you're doing extension 2, you're pretty confident in doing stuff in extension 1 and mathematics. Alright, so the square root of, what was it? 5 take away 12i is equal to a plus bi plus or minus a, 3 minus 2i. Does that make sense?
I'd like to say so.
Hey?
I'd like to say yes.
Or are you too comfortable with me writing it like this?
Yeah.
You know what's going on?
Yeah.
No, yeah. I know.
Yeah? So you don't have to write like that, but that's a nifty little way to do it. Alright, so the alternate way to answer that particular question is to consider the following. Okay, so we had set over there that a squared take away b squared is x and 2ab is equal to y, where x and y are the real and the imaginary part respectively of the complex number that we are trying to find square roots for. Okay, so we want to write down the following. So using those two, 1 and 2, we want to use 1 and 2, so we're going to go x squared plus y squared. Okay, because I know the result from something we've already done in complex numbers that has x squared and y squared in it. Okay, so x squared plus y squared, a squared take away b squared or squared, that squared, plus 2ab, that squared. Okay, so expand that out. A to the 4 minus 2a squared b squared plus b to the 4 plus 4a squared b squared. Tidy it up. How can I write the next step? How can I simplify that further? Pardon?
Factor over
How?
a squared. Yeah.
Okay, so this is your x squared plus y squared equals that. Then take the square root of both sides. Okay, so we could consider it as plus or minus the square root. However, we just need the positive because it doesn't matter because we're going to square it anyway to get the value for x squared plus y squared. So we don't need to consider both the positive and the negative. Okay, and we use that result. So if the square root of x plus yi is equal to a plus bi from before, so the alternate way we can go, so a squared take away b squared is equal to the real part, okay, which is what I've had already. Right, and then a squared plus b squared is the square root of x squared plus y squared. Alright, using that result I've just derived. Alright, Now the key is this. So if y is greater than 0, a and b are of same sign. Okay, and if y is less than 0, a and b are of opposite. Okay, and that's the other reason why we don't have to consider plus or minus the square root there. Okay, we can use this concept here. So you can remember that. That will save you quite a bit of working to consider whether the solutions are positive or negative. Okay, so let's look at an example to incorporate that. Find the square root of 5 minus 12i. So exactly the same as what we've done before, using now this second method. Okay, so the same setup in terms of you're solving for a's and b's in there, because what you're really doing is finding the solutions that match this. Okay, so using these two. So a squared take away b squared is x. Remember this is x, that's y in there. So that's going to equal 5. And a squared plus b squared is the square root of x squared plus y squared. So 5 squared plus 12 squared is... Hey?
Yes, it is. You have x squared. You have x squared plus y squared.
Alright, so what's 5 squared?
25.
What's 12 squared? 144 plus 25 is? 169. Square root of 169 is? Fantastic. Hey, you like that? Whole numbers, no surds. Okay, so this method works well if we have what's called a Pythagorean triad. Okay, this works really well. It can be done if you have a surd, if we're just going to look messy. Okay, so if you're getting a surd, you're probably better off using this method here. Okay, otherwise you can do it here if you don't have surds. But in particular, it will make things a bit easier. So 1 and 2, so you're going to add 1 and 2 together, get a's. Okay, because the other reason is they are the same coefficient, so if I do an addition or subtraction, it's going to eliminate one of your variables. Okay? So 2a squared is equal to 5 plus 13, 18. A squared is 9. Okay, so we're just considering our positive solution because we're going to use this concept to determine the signs, okay? Well, are we? Yep, just for the time being, because we will use this concept at the end. Okay, so you can consider them positive, negative. However, when we square them, you're always going to receive a positive value back, aren't you? Alright, so put that into number 1. So we have 9 take away b squared is 5. So b squared is going to be 9 take away 5, which is 4. So just looking at the positive solution, you've got 2. Okay, which was the same answers as before, but it's opposite sign in them. Okay, and that's where this comes in here. Okay, so is y greater than or less than 0? Less than 0, so the A and B are opposite sign. So,
matter which, if A or B are which, like which one's negative?
Well, we had two of them here, didn't we?
Oh,
That's
Yeah.
cool.
So if A is positive, B must be negative, and if B is A is negative, B must be positive, and that's what this will incorporate. Okay. That way, we don't have to take plus and minus square root here. We don't have to do this plus and minus business here, because when we square it in this concept here, we're going to get a positive, aren't we? All right. So that's just a fallback method rather than doing all the extra work. If you can remember this concept for this style of equation, okay, that'll give you a solution. Okay. So, so the imaginary part of Z is less than 0, so it implies A and B are opposite in sign. So therefore, the square root of 5 take away 12i is equal to plus or minus A minus BI. Oh, sorry. Yep. Plus or minus A, which is 3. 3 take away 2i, which is what we had before. Now, last one for today. So we need to solve 1 plus I z squared, take away z, take away I, is equal to 0. Expression of solution in the form A plus BI, where A and B are real. That's really nice. Alright, now, I've already told you at the start of this lesson that conjugate pairs occurs when the coefficients are real. Okay? However, in this one, the coefficients are not real. Okay? So we do not have solutions in conjugate pairs. Right, so we need to go ahead and find the solution. Any suggestions how you're going to do that? Something we've already done today. A couple of things we've already done today.
finding the roots.
Yep. So Z equals, well, we're not going to factorise by two numbers multiplied to give negative I, and same two numbers add to give negative 1. Okay, so what's the alternate way we can answer that? The quadratic formula. Alright, so minus B plus or minus B squared minus 4 times A times C all over 2A. AC. I. Minus I, not minus 1. Okay, so we want to find the solutions for this quadratic involving complex coefficients there, and we have take the square root of a complex number. Okay, so we need to go back to that concept there and do that, perform that for that section there. Okay, because you're just looking at this part here. Okay, that's that again, isn't it? Okay, so the square root of -3 plus 4i, we're just looking at that part of it now, so that we can continue to find the complex roots. Right, so a squared take away b squared is the real part of here, which is -3, and a squared plus b squared is equal to the square root of x squared plus y squared. And I'm using this one because I've identified that 3, 4 makes the Pythagorean triad. Okay, so 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. Okay, so that's why I'm favouring this side, because I've got integers as part of my solution there. Okay, if it doesn't work out, you have to consider the first method that we solved, finding the square roots. Okay, so number 1, number 2, I'm going to add. Okay, so 2a squared is -3 plus 5, which is 2. So a squared is 1, a is 1. Okay, remembering we're using the sign of the imaginary number to determine whether a's and b's are positive or negative in relation to each other. Into 1. So 1 minus b squared is -3, so b squared is going to be -3.
4. So positive 3.
Yep, nothing here, I'm just confused, so with that, 3 plus 1, so b squared is 4, b is going to be 2. Alright, so now we need to consider the sign. So imaginary part positive or negative? Positive. Okay, so the imaginary part of -3 plus 4i is greater than 0. So that implies a and b have the same sign. Okay, so now we can go back to this point here. What's up to 3? Okay, so so we now have a plus bi, because they're the same sign. Okay, where a is 1 and b is 2. So we have 1 plus 2i for the positive part of your solution for your quadratic. Okay, so technically it is of course plus or minus 1 plus 2i. And because they're the same sign, I'm putting a positive in the middle. Okay, put that into 3, back into that quadratic. Didn't really matter the plus or minus because I've already got the plus minus as part of my surd. So z is 1 plus or minus the square roots of -3 plus 4i, which is what we just determined, over 2 plus 2i, expanding the denominator. Okay, so z is 1 plus 1 plus 2i over 2 plus 2i, and z is 1 take away 1 plus, sorry, negative 2i, all over 2 plus 2i. Okay, so z is going to be 2 plus 2i over 2 plus 2i, which is 1. And z is going to be negative 2i over 2 plus 2i. Are we finished? Why not? Okay. Well, 2's not in form a plus bi, where a and b are real. So how do I make it a and b is real? Good. So negative 2i over 2 plus 2i times 2 take away 2i over 2 take away 2i, multiply by its conjugate, on top bottom. So negative 4i plus 4i squared over 4 take away 4i squared. So it would be negative 4 take away 4i over 4 plus 4, which is 8. Okay, and there's your solution where a and b are reals, and negative 1/2, take away 1/2 of I. Okay, so you got to watch your signs when you have I squared.